You can see my screen?
Yes, I can see it.
Yes, yes.
Yes. Okay. So today we are going to uh, see all these things like virtualization, Docker, Kubernetes, Helm, GitOps, and jobs and career related to these things. So when it comes to virtualization, it enables the hardware resources of the single computer processor, memory, storage, and more, which is divided into multiple virtual computers. Okay, so this virtualization is a technique which transforms the hardware into a software. So, so for example, I am teaching you guys. So we are in the class. Okay, so I am teaching you, you can hear me. Whatever I'm telling you, you are understanding it. So the same things are going on, right? But we are virtually we are not, it is not present. But you can see me virtually, but physically you cannot see me, right? So that is what it actually means. So when it comes to there are two things, development and operations. Okay, so when it comes to development, what developer will do? He will write the code. Okay, the development will write the code, run the applications. So once the development things are done, again it will send it to the testing. So further testing, what happens when it's sending to the testing might get failed. Why? Because the development is have written the code correctly, but why it is failing here in that testing side? Because maybe the OS which he is the development while creating the applications or writing the code, he might be using the um, using the operating system or whatever the operating systems and software whatever he has used, the versions might be different. And where the same versions might be different, he might be using some 2.3, he might be using for the testing, he might be using some 2.2 version or something. So because of small these things, it might get failed. Okay, so in this case, what we are supposed to do? Again, this tester will tell that this code is not working properly. Again, he'll send back to a developer. So in that case, what happens? So how we are going to solve these problems, these kind of issues? So we can do one thing. We can send the OS plus whatever the software he have used, he can send it, and whatever the applications, whatever the libraries, whatever the dependencies are there, this developer can send it to the tester, so that he can run the code on that only. Then it will be successful for this tester, right? So in real time, what happened? We cannot share our OS to the tester. So how we are now going to share the tester, share the OS and these things to them? Then virtualization comes into the picture. So in virtualization, what happened? Infrastructure, this is nothing but the hardware. Okay, hardware is nothing but your laptop, your PC, whatever it is. This is hardware. Okay, so hypervisor. This is nothing but the type one hypervisor. Okay, so in the virtualization we have type one and type two. Okay, so this is completely into bare metal. So on the hardware, we'll put directly the hypervisor, which comes like bare metal. Okay, we don't have any software here. Directly on the hardware we are putting this hypervisor. Okay, so on this hypervisor, we are creating the virtual machines separately. For suppose this is a virtual machine, here we are using the OS. Okay, so here whatever the OS which we are using, this is the guest OS. Okay, then application runs here. Okay, so for in the hardware, one second. If you can see, this is This is the hardware. Okay, on the top of it I kept hypervisor here. Okay, this is the hypervisor which we have kept here. So don't go with the handwriting. Okay, sometimes this brush doesn't work properly. So here what we are putting, the VMs we are putting. So here for the hardware, if suppose we have the 16 GB here, 16 GB we have. Okay, if you can see this, uh, so for one laptop, for suppose you have taken one laptop. Okay, so this costs around 1.5 lakhs, assume like that. So if it is like 16 GB, 8 core CPU I have, and 1 terabyte hard disk. Okay, so now what's happening in the play, if I have bought this laptop, only one person can work on it. Okay, if I do the virtualization here, two people can work. How I am dividing it? I am dividing the work like, if I'm using the 16 GB, I have given 8 GB to one person and two core, and 8 GB to one person, two core. So two people are working. Okay, so this is a concept of virtualization here. So internally what's happening is, here if you can see here, 16 GB and 8 core CPU, if I have this, for one person I have given the 8 GB, for another person I have assigned 8 GB. Okay, like that I am dividing the work. So when I am dividing this GB, storage things and everything, three different people can work. Okay, like that, in the same way I can give it to 10 other people. Okay, so this is the concept of virtualization. This is how it works. Okay, if you can see the real time example, if you can see, everyone has mobile phones, right? Everyone will be using it. So we have the internal storage and external storage both. For example, external storage you have, internal storage you have 16, and it is not enough. So what you do, you insert one card, right, for the storage purpose. So what happens exactly there? So both the storage will add and it will show the 48 GB, it will show to you. Okay, it won't show like this is half and this is separately, it won't show. So 48 GB it will be showing you. Okay, this is the real time example. So if so this is the thing here. And when you comes to the second example, what happened? If suppose there is a requirement of 150 GB here, so how you are going to take it? So 50 GB only, maximum we can get in the market, right? So we are taking these things and we have adding up these things, then the storage will be 150 GB, like this. We are adding up these things, this is nothing physical. And when we are doing the virtualization here, 150 GB we got. Okay, so once one storage is get interrupted, one storage is like corrupted, the remaining all these things will get corrupted. Okay, this we can use the redundancy for this, and the rate of the technique we can use to solve this corrupted problems. Okay, so here what happened, the data is stored in the form of LUN, logic unit number. Okay, whatever the 50 GB we have, so all these things are added here. And then it is like a building, building the some block. Okay, it is comes under block and the data is stored into 150. Okay, this we can call it as logical, which we have doing the virtualization. Okay, so it is breaking one system into the multiple systems. So this is nothing but the virtualization. Okay, then what is hypervisor? So we have used the hypervisor here, right? So what exactly it is? So a hypervisor is also known as a virtual machine monitor. Okay, it is a software which creates and runs the virtual machine. Okay, so this is nothing but a software. This allows one host computer to support the multiple guest VMs by virtual sharing its resources such as memory and processing. So this is a type 1, and this is a type 1 and type 2 hypervisors. For the type 1 hypervisor, what we have, this is the bare metal. Bare metal is nothing but on the top of the hardware, we are directly putting the hypervisor here. Okay. For the type 2, what we are doing, for the hardware, we are putting some OS, Windows, Linux, whatever it is, we are putting one OS. Then we are adding the hypervisor, and remaining will be the same as the type 1. Okay, so why we are using it? For suppose I have already given one example to you. If you are having the 16 GB here, you are dividing this to one VM and one person is working on it. Okay, when you see the virtual machine here, we have the guest OS here. Okay, we have OS here and we have OS here also, and then we have the software, we need to install it. Once the software is installed, then the application will run here. Okay, it's just like a new laptop. Okay, most of the companies will be using the type 1 hypervisor. Okay, type 2 hypervisor is used for the learning purpose only. Okay, and moreover, when we go, more slides, then we can see the actual difference here. What exactly? This is these examples and these things we can see in the more slides. Okay, here it is. Like, what is the difference between type 1 and type 2 hypervisor? So here, for this criteria, bare metal is used. And for this, hosted OS, we will be using it. Okay. So here, virtualization, hardware virtualization is there. This is OS virtualization is there, and this runs directly on the system with the VM and runs on them. And this is a conventional operating system. Okay, when it comes to operation, guest OS will be there, and application runs on the hypervisor. And here for the type 2, it runs on the application on host OS. For scalability, better scalability is there, and here the scalability is not there because of the underlying the OS. And the setup and installation here, it is simple, and a lot, as long as you have the necessary hardware support, it is very simple. So when it comes to type 2, a lot simpler setup, as you are already have the operating system. Okay, so system independence has the direct access to the hardware along with the virtual machine it hosts. And for type 2, these are not allowed, directly access to the host hardware. Okay, the speeds will be faster here and the speed will be slower because of the system dependencies. So when it comes to performance, high performance will be there as there is no middle layer. So obviously this will be reduced, performance will be reduced here because we put one OS there between the hypervisor and the hardware. Okay, so a security, this is more security, this is less security as this is a bare metal thing. Okay, so examples. So VMware, for the VMware only, for virtualization, how we have the hypervisor, same for the VMware, we have the ESXi, which is a hypervisor for this VMware. For the Microsoft, we use the Hyper-V, and for the Citrix, we use Zen Server. So most of the companies, top MNCs or whatever the company, software companies will be using all these hypervisors, and all these things they'll be using it. Most of them will be using the Citrix. So when it comes to type 2, this is for only learning purpose we'll be using, like virtual box you people will be installing, and for the learning purpose you can install in your laptop and work accordingly, and a virtual PC and workstation players. So now virtualization versus Docker. So why Docker comes into picture? So why? Because here when I told you, here we have the OS. Okay, this is the guest OS. Here also we have the OS, right? Okay, so here then we have the guest OS. Why it is called guest? Because already this is the actual OS, and again we are like installing the OS here, and this comes as a guest. For example, this is your own house where your relatives comes to your house, and okay, those people will be coming for few days and going away. So this just like a guest. Okay, so here the application runs here. Okay, so why we come to Docker? Because Docker also the same procedure which we are using here. But what exactly happening here is, here is the hardware, here we are putting one OS, here also we are putting the OS, here we are putting the hypervisor. In the place of hypervisor, we are using the Docker engine or container engine, whatever you call. So in the place of virtual machine, we are using like container. Okay, we'll call it as container here. So here also the same applications will be running, and binary and libraries are running. Okay, but what the thing we don't have in this is OS. Here we are using the guest OS, here we don't use any OS, because if the container is running, same process again you have like 16 GB, you are giving this person, you are dividing the work like 8 GB you are giving to this person, each person you are giving the 8 GB or 4 GB, you are dividing it. Okay, here also we are giving the same, like if you have like 16 GB or 32 GB, whatever, we are giving the same to one person. And here what exactly happens is, the container, how much, if this container requires like 4 GB, suppose it will take the 4 GB and it will work, and after once the work is done, again he will return back that GB to this OS. Okay, so here what happened in virtualization, this concept is not done, because if this person, we are assigning 8 GB to this person, that means whether this person use it or he doesn't use it, this amount of RAM is assigned to only this person. Okay, so this complete virtual machine we are assigning to one person. This completely we are assigning to one user. So there are three, means we are three different people we are assigning the work. Okay, so for that person, whether he use it or he don't use, we are giving this much things to this person. This much RAM, this much CPU we are giving to this person. Okay, whether he use it or he doesn't use. So when it comes to Docker thing, what happens, he will take the same GB if the requirement is for 4 GB, and like that it will take it and it will use it and it will return back to the OS. Okay, again if he want the 8 GB or something like that, it will take it, he utilize it, again it will return back. Okay, so that is a difference between machine, virtualization, and the Docker. So, what are the benefits here? What are the benefits here is, so we can minimize the downtime, and obviously the cost will be reduced here. So capex and opex, capital and operating cost will be reduced. uh, this means exactly, for example, if one person is putting one company, so if the person is putting one company, means he have to give the electricity bill, and whoever the whatever the employees are there, everyone he have to pay, and for the systems he have to buy each and every system for so many people, 100 systems. If suppose he have 100 employees, he have to buy 100 laptops there. Again all these are the capital thing only. See, one time if you are buying, that comes under capital costs. If regularly if you are giving the amount to that person, is operating costs. Okay, so one time approaches, if you are buying the ACs and all, one time only you will buy it. So all these things comes under the capital, this thing costs. Okay, so operating things, for employees you have to give the regularly monthly basis, you have to give your employees the salary and all, that comes under operating. And bill and all, whatever the bill is coming, electricity bill or whatever, So for that, these things comes under operating costs. So all these things will be reduced if you use the virtualization concepts. Because if you use for one laptop, if you are using 10 employees are working with the help of the virtualization, so obviously the amount will be reduced, right? So it will increase the IT productivity and efficiency, and it is faster provision of applications and resources, and it is very user friendly. So when it comes to Docker, I think I have cleared a few topics. I mean, what exactly the Docker is, I have shown you there. So still, this is the definition. If you want to note it down, you can note it down. If you guys are not understanding, that's okay. But again, we are going each and every session. We'll be taking 7 to 8 sessions. We'll be taking after this. Okay. Again, we'll go into the much deeper. This is just an overview, which I'm like explaining you what exactly it is, why it is. Okay, only the overview we are looking now in this demo, but again we can go into the depth. Okay, day by day. After the further classes, we are having 7 to 8 sessions in one topic, so we can see it deeper. Okay, so when it comes to a Docker, it is nothing but a containerization platform. Okay, which which packages your application and all these dependencies together in the form of containers. So whatever the containers are there, we are taking it as a packages, and whatever the dependencies, the libraries, whatever the dependencies are there, all those things we are putting as a container. So Docker containers wrap a piece of software in a complete file system that contains everything need to run code, runtime, system tools, system libraries, etc. It wraps basically anything that can be installed on the server. So how the Docker containers are created? So first we'll be creating the Docker file. Okay, so once the Docker file is done, then we'll build it. So once the building means we have the few commands here. Okay, for building and for running things, we have very commands which are very easy. I'll tell you in the later lectures. Okay, so we have to build the command. We have to give the command called build, Docker build. Once you give the Docker build command, then the Docker image will be created. So once the Docker image is created, then you can run this Docker run. You have to do that command once you give, then the Docker container will be created. Okay, so what exactly Docker file is? So Docker file can build the images automatically by reading the instructions from a file called Docker file. So this Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. Using the Docker build, the users can create an automated build that executes the several command line instructions in the succession. So don't get worried what is Docker file. This is just first in the starting level, it will be like Docker file only. So that once you give the commands only, this is very simple and very easy. No need to get worried here. Only we are giving here simple commands. Okay, so once we complete all the Docker theory part, then we can go to a practice session where I will providing you all the commands which are very easy to remember. So once you give those commands, then the Docker images will be created, then the Docker containers will be created here. Okay, so basically in the Docker we just create the images and we create the containers. Okay, once the images are done, we'll put it in the Docker hub. I think you might know the GitHub. Okay, the same way for the Git we have the GitHub, for Docker we have the Docker hub. Okay, so whatever the things we created here, we'll just put it in the those hubs, so that what happen when the other person in your team, if he is working on the same thing, if he need this Docker image or something, if he is working on something, if he need this Docker image, then he can Unnecessary, again he'll go to the Docker file, again creating the Docker file, build again, creating the Docker image, no. So after doing all these process, already one person will be kept in the Docker hub. So from there he will pull it, pull the image from there, and then he will work on that, then he will run the thing. So automatically the Docker container will be running, right? Unnecessary these steps he won't follow, right, when you already have the GitHub or Docker hub. Okay. So same thing. So Docker images are used to create the containers. Okay, when a users run the Docker image, the instance of the container is created. These Docker images can be deployed to any Docker environment. What exactly the Docker container is? These are basically runtime instance of Docker image. Whatever the Docker images are there, once you run that command, then the container will be created automatically. Okay, these includes the application and all its dependencies. So whatever the dependencies are there, that also installed, okay, that also will run. So they run on any computer or any infrastructure, or in any cloud. Okay. So Docker hub we have. So Docker images are created, Docker containers, and here we have has to be a registry where these Docker images live. So these registry is called Docker hub. Okay, Docker hub is nothing but whatever we create, whatever the code we write, whatever the images are there, we'll make it into the images, and we put those images into a Docker hub. Okay, whenever the person wants to, if suppose you have cooked the food. Okay, so you are cooking the food, and you are keeping into the refrigerator. Okay, and next day when you are like hungry, again you won't make the food, na. Every time after 1 or 2 hours, if you are like hungry, what you do? You go and you won't cook the food, right? If it is in refrigerator, you go and take it and you eat it, right? The same way, the Docker hub. Okay, when the things are ready, just you go and you take it and you work on the things. Okay, so this is just like a which is already ready. Okay, this is nothing but the Docker hub. Okay, so when it comes to the practical things, all these things will be very simple to you. Now this might look very, uh, very difficult, but this is not that difficult. These are very easy things, and once you complete the theory part, no, once you understand what exactly it works, and once you learn the commands, this is going to be very easy. The users can pick up the images from the Docker hub and use them to create the customized images and containers, which I have already told you. So when it comes to architecture diagram, you can see this is the client. In client we can see Docker build, pull, run. Okay, so this is the Docker host. Here we have all the containers and the images. This is a Docker daemon. Okay, this is a registry is nothing but the Docker hub. Okay, in the registry we can have like different I mean like open stack, these all these things can be there here. So in the from the client, what we do, the Docker pull command, when you give from the Docker registry, will be getting the images here, and we can build it, we can run it. Okay, and we can make the containers here, and these are the container. Okay, so what is exactly the Docker client? These components perform the build and run the operations from the purpose of the opening communication with the Docker host. Okay, there is a communication with the Docker host and the Docker client. So these Docker host, this is a component. This have the main Docker daemon and host containers and their associated images. And these daemon establish a connection with the Docker registry. So Docker registry is nothing but the Docker hub. Okay. So Docker registry, these components stores the Docker images, and they can be public registry or private registry. Okay. So Docker hub can be a two types, which is public and which is private. when it comes to company to company, IT companies will have the private Docker registry. Okay, if you keep it public, then everyone will be using it. So most of the public registry will also be there, but it is for the practice or learning purpose. Okay, most of the companies won't share their data with any other. They won't put it in the public, so they'll be using the private. For this, we have to give some, amount. So basically, for the private thing, the company will be doing it. Okay. So the most famous public registries are Docker Hub and Docker Cloud. Okay. So when it comes to Docker container lifecycle, first what happens? It will get created. Once it is created, then it will start running. Okay. Okay. It just start running. Once this is running, it might go into pause state, or you can unpause it too. Then it is stopped or it get deleted. For these things we have the commands. Okay, for the Docker also we have the commands. Again, in the more depth for the life cycle, again we'll have the another session in the future. Okay, so we can see it clearly, so no need to get worried here. So what is Kubernetes? Kubernetes, why the Kubernetes has come now? So you understood what is virtualization, and why we came to Docker. Docker is nothing but the advanced version of the virtualization, right? So now why Kubernetes? Okay. Kubernetes is the open source container management tool. It holds the responsibilities of the container development, scaling, descaling container, and load balancing. Okay. So it is a Google's brainchild actually. So this is like have given to a CNCF. They have that person has taken this one. So why Kubernetes? Kubernetes, what it does, it does not create the containers. Okay, only Docker will be creating the containers. What Kubernetes will do? Kubernetes will just manage the containers. Okay, it is just orchestration tool. Orchestration tool means it only manages the things, whatever the automates. It will automate the operational task of the container management. Okay, it is just to operate. Okay, this Docker is just like a ship, and Kubernetes is just a with this Kubernetes only we can drive the Docker. Okay, so this includes the built-in commands for deploying application and rolling out the changes to your application, scaling your applications up and down, okay, and fit the changes needed, monitoring your applications. Okay, so actually what you need to understand is why we use the Kubernetes, because Kubernetes is used just to operate the Docker. Okay, you understood what is virtualization, right? So once the virtualization is done, why it is an advanced level of virtualization is Docker. Okay, once the Docker is done, to manage all these Docker things, we need Kubernetes. Okay, so as of now, you understand this. After that, again, we are going into when we go into the depth, we can understand what exactly it is. Okay, so when it comes to architecture, assume this is a cluster. Okay, okay, so this is the complete cluster. Okay, cluster is nothing but where we for example, if you are building something, you're building, or house, where exactly your house will be there? It will be on some land, right? So think like that. This is just a cluster. Okay, so on the cluster, what happened? We have the nodes. So we have two types of nodes. One is master node, one is the worker node. Okay, so what we have taken, if you can see the diagram here, the master node, one master node we have taken the two worker nodes. Okay, so when it comes to master node, okay, we can take anything like master node, we can take five, we can take worker nodes five, any count based upon your project, based upon your requirement, you can take it. Okay, so for master node, if you can go inside the master node, these are the components which present. Okay, for the master node, we have API server here. we have the controllers, schedulers, okay, we have etcd, okay. So for the API server is nothing but the communication between the worker node and the master node, okay. So there are so many components here, but they won't talk to each other, okay. These controller won't talk to scheduler won't talk to etcd, okay. This will only talk to API server, okay. Only API server is the only person. He's a kind of agent, okay. If this controller have any problem, it will go to API server, okay. Then, okay, he is the point of contact, okay. So here the same way for the worker node we have the kubelet is a person, okay, where whatever the components are there, for behalf of all that, only the person who talk, okay. This is an agent service, okay. This will be talking to this API server, okay. This will communicate to only this person, okay. Clear, right? So as of now, API server is nothing but communication between the worker node and the master node. Don't worry, again we'll go step by step, we'll be going, okay. When we comes to Kubernetes, again we'll cover all these things again. So as of now, API server is nothing but communication between the master node and the worker node, okay. This API server won't talk to pod or anyone, okay. It will talk to only kubelet, okay. So now in the API server, this is the API server work, okay. Control manager, what he will do, it will see the track, it will check the status of the complete cluster, okay. In this node, worker node, first suppose this is worker node 1 and this is worker node 2. This controller will check whether this is working fine, whether the what is the track of it, is everything is good or not, okay. etcd is a not a part of Kubernetes, is from, it's a just a database which we have taken from the outside, okay. etcd is stored in the form of key value store, okay. Key value format, it will store the data. For example, key is nothing but name, okay. Name is equal to, key is equal to value, okay. For example, key is name is equal to Zarina, okay. So the name we have given, so it is kind of key value, okay. Next, college is equals to, what is the value, so and so name of the college, okay. Roll number is equal to so and so roll number, okay. Employee is equals to so and so, okay. This is nothing but the key value format, right? So in the same key value form, the etcd will be stored, the data will, this is nothing but just a database which will be storing all the data here, okay. That is the thing. So for suppose the pod is running, okay. What is pod now? So pod is nothing but, okay. So the, okay, I'll come back here. So this is the node components. So in the node components we have kubelet, okay. This is the kubeproxy. These are nothing but pods. In the pods, inside the pods we have the containers, okay. Containers are nothing but, again, the same docker images, okay. From the docker images only we made the containers, docker containers, right? Those docker containers in the Kubernetes, what we do, we'll put inside the pod and we will run them, okay. Containers are nothing but the applications and whatever the things are there, we will be creating as an image of those, and that images we will be running as a docker containers, and these docker containers are kept inside the pod, okay. So for suppose this is the pod 1, okay. This is this circle is one pod, okay. Inside this pod, this is the container, okay. So so you know what is container, right? So inside, containers will be placed inside the pod, okay. For one pod, if one container is there, then it is very healthy, okay. If you can put 2 to 3 pods or containers also in one pod, but what happened, it will be tightly packed, okay. For suppose if one container got failed, what happens? The complete pod will get crashed, evicted. Okay, one container is like failed, the another container will be working in the place of that container. That is okay, but again, if something happened, the complete pod will get crashed. Okay, so for this pod, you can see this IP address, right? 10.10.20.1. What is it? It's a IP address. So IP address, we can put this IP address to each and every pod. Okay. For the communication purpose, we'll be putting this. Okay. For this pod, for each pod, we will be giving the IP address, not for the containers. Okay, so now what we are seeing here is, so this is actually the pod is, okay, the blue color is nothing but the volumes, the just for the storage purpose. Okay, so for suppose this is a pod and this is a container, we have two containers, one container is like failed or whatever, it got crashed. So in the place of other container is there, so this work will be does not stop. Okay, his work, it will whatever wherever it has stopped, it will go to the volume, it will check and it will take that work, and this another container will be working. Okay, in the place of this other container will be working. Okay, if this get failed or if it get crashed, the other container will be working in the place of this. Okay, so for the communication between the containers, we need the IP address. Okay, from one pod to another pod, if you can see the architecture, see, in the pod, within the pod, two to three containers will be there. How are they going to communicate with each other? With the network, okay, with the proxy only. How for the local host, okay, for the local host only they are going to communicate. Okay, for one pod to another pod, how the containers can communicate? Those things we can see in the coming lectures. From one container to another container, how the containers are communicating, how they are sharing the data, how the work is going on inside this pod, those things. And and how the containers are from one pod to another pod, how the containers are communicating. Or for the one complete node, okay, for example, this pod one is there, in this we have one container, how this container is talking to this container here, how they are communicating. Okay, those things we are going to see in the coming lectures. Okay, what happens if complete worker node got failed? What is going to happen now? If complete one worker node got failed, okay, or one complete worker node got crashed, okay, so what going to happen, how it going to run now? Okay, so if complete one pod is got failed, okay, there are three pods here. Okay, one pod is completely crashed. Okay, so what going to happen in this place of one pod? So does this Kubernetes going to create another pod in the place of this? And what about the IP address? Okay, how you are giving the IP address? If the same pod is like crashed, for this one we have the one unique IP address will be unique for each and every pod. Okay, for this pod, if we have the unique IP address, if this pod got crashed, if the Kubernetes created new pod, for that also we get a new IP address, right? Then how the work going to, how they are going to work then? So for every time you will get the new IP address. How? So for those concepts, we have the service here. Again, we in service we have different types of service. Node port, cluster IP. Okay, cluster IP will be the default. Within the cluster, it will see node port means outside the cluster also the services can run. Okay, how we are doing the load balancing. Okay, for the not only for the communication purpose but also for sorry, so for also the pod, how this pod will get crashed, so how the new pod is, how it is creating, how this is going to automatically, how it is going to happen. Okay, so how it is going to happen? Replica set, while creating the deployment we will be putting the replica set. Okay, how many desired state will be there, actual state will be there, so all these things we are going to see in the coming lectures. Okay, so as of now you understand there are two types of, okay, components. which is master node and the worker node, and these are the components of those. Okay, once you are as of now you understand these components and look see the components, how it works and what it does. Okay, in the coming lectures we can see how the cluster is working, how we are going to create the cluster, how, okay, for the creating clusters, how the companies are going to create the cluster. For creating cluster also we have different types. Bare metal we have, and by using the cloud also we can create the clusters. Okay, GCB, AWS, Azure also we can create the cluster. Okay, the master will be managed by the cloud people only. Only worker nodes we need to see if we are going with cloud. Okay, if you are going with bare metal, everything manually. Okay, everything manually you have to do. Even for master node got failed, for example, how it going to survive, how the cluster going to survive, all these things we need to see. Actually all these things we have to do it manually. Okay, what is resource quota, how we are going to manage this. For this particular pod, only this pod should be on this worker node only. How we are going to put all these things, how we are going to manage these things, we are going to see all these things in the coming lectures. Okay, so for the pod life cycle, here also same. For kubectl commands we'll be giving it. Okay, so for the kubectl commands, if you run the kubectl get pods, so you can see the list of pods, how many pods are there in the cluster. Okay, kubectl get deployments, you can see how many deployments are there, how many replica sets we have kept up, all those things we can see. Okay, so if you can see kubectl get pods, if you give, so it will show you the status of the pod. Okay, it will show the name of the pod, then it will show how many uh, pods are running. Okay, total, how many, the total number of pods divided by total number of pods in the cluster and how many are running, that it will be showing, and it will be showing the status of the pod. Okay, if the pod is in pending state, it will give the name of that particular pod and it will show the status, whether it should be in pending state or running state or successful state or unknown or failed. Okay, and when it comes to failed means there are n number of reasons. Okay, image pull back of error, and you can see so many errors like create container creating errors. Okay, and how to debug that, how to, you know, troubleshoot these kind of failed issues when this is pod has terminated. Okay, one or more containers in the pod has terminated unsuccessfully, so it will get failed. Okay, so when it is failed, how you going to troubleshoot this? Okay, succeeded means only in the Kubernetes you have jobs. Okay, you have con jobs also, that will be comes under succession means all containers in the pod have terminated successfully, means it will run and it will completed. Once it is completed, it will come into the succession state. Okay, running means at least one of the containers defined in the pod is still running. If it is still running, then okay, this is the meaning of it. Okay, so when it will be in pending state means the pod is in pending state until its containers are started. So if you are just created the pod. Okay, for creating the pods we have very simple commands, no need to get worried. Only simple command, by we have in the commands also we have imperative commands and declarative commands. Okay, so for writing, for the creation of pod we can write the manifest like YAML file. Okay, for if you don't know the YAML, I can teach you what exactly the YAML is. Okay, if you know the basic understanding is there, that is enough. Okay, so for the pod creation, we can have the YAML files and we can also use the imperative commands. Okay, if you give one command, the pod will be created itself. Okay, later once in the backend it will write the YAML file, then you can go into that particular YAML file, then you can make the changes there based upon your project's requirement. Okay, So I'll show you in the coming lectures. I'll show you what exactly the YAML file is, and for the pod, pod, for service, for deployment, for each and everything, we'll be writing the YAML file in the backend. Okay. So if you can know the Linux, okay, there you can use the VI editor. So there you can write the YAML files and all these things you can write it. I'll show you step by step. Will be going into that. Okay, if you can give the imperative commands, if you give one command, no, then also it will get created. No need to get worried about the, if you don't want to, like, if you don't understand the YAML also, then we can give one command and we can see. Only understanding is also fine. YAML is not that important to do it. Okay, so now the other concepts is Helm. So it's a package manager. Okay, so that makes it possible to download the charts, which is packed collections of the necessary version. These are the definition, guys. If you want, you can note it down. Okay, so Helm is nothing but Helm, it is easy and automated manager. Okay, so Helm basically we'll be using into Kubernetes. So it will be very easy for us to install whatever the charts are there, whatever the things are there, if you want to download. So for the installation purpose and update purpose, we'll be using the Helm. Okay, so by using these Helm commands, it will very easy in the Kubernetes to whatever the packages are there. We will be having the Helm charts, different Helm charts will be there. So for those things, we have to download it, we have to install it, and we have to upgrade it. Okay, by using the Helm template command also, we have so many commands here. So no need to get worried. Once the Kubernetes is done, once the Kubernetes is done, Helm also is very easy to learning purpose. Only few commands will be there. Okay, for those few commands only, you have to only basic commands will be there. Some 15 to 20 commands will be there. If you are okay with it, then you are good to go with Helm. Okay, only this is just a theory part, what exactly it does. This is just an overview which you need to know. This is the basic thing. So once you know the basic things, once you know the commands and all, okay, you can work accordingly. So it can be a time consuming, and this can write and maintain the Kubernetes YAML and manifest for all the essential Kubernetes object. You'll need to at least three YAML manifest with the duplicated and hard coded values of the most basic deployments. These help streamlines and the process of generating the single package that can be distributed across the cluster. Okay, so basically, in the companies, what happened? They have the Helm charts. Okay, in the Helm charts, they have different Helm charts. They'll be keeping the names to their Helm charts, and so according to each team, few whatever the few charts are there, they are responsible for those registry, like complete those registry, and whatever the SGs are there, service groups will be there. Okay, for these particular groups, service groups, these team will be managing it. Okay, so so for example, there are five different charts are there, or 10 different charts are there. So four to five owners, for this owner, one team will be the owner for that. Okay, whatever the changes are you are doing in that particular code. Okay, the if you have 10 charts, if you are if other people want to work on that, so what exactly you are doing, you are giving these charts to them, and they are working on it. Okay, so if they are making any changes, then you are the owners to that, so you have to give the permissions accordingly. Okay, so when it comes to Helm, these Kubernetes automatically maintains the database of all the versions of our releases. So whenever the something goes wrong during the deployment, the rolling back will be there. To rolling back to the previous version is just one command away. Okay, so rolling back we have in Kubernetes too. Okay, in the Kubernetes we have rolling back, and okay, rolling back also we have, and we have the strategies also in Kubernetes. We'll be following few strategies, and scaling will be very good, and scaling, descaling, okay, and horizontal and vertical scaling, all these things is there in Kubernetes, okay. So here also we have the rolling back, okay, when it comes to deployment. So in Kubernetes we have Docker Swarm also. I mean, in the Docker we have Docker Swarm also, but most of the companies prefer Kubernetes. Okay, because of this, it is very easy to work, and it is user friendly. Okay, when it comes to Docker Swarm, there are few differences. We most of the people doesn't use Docker Swarm much. In a coming lectures we can see that Docker Swarm also. Okay, so as of now, this we are using the Helm 3, okay, which is the latest version Helm 3. It is released on November 2019. So how does the Helm works? So Helm is used in deploying the charts as the package applications. They are the collections of a pre-configured application resources that can be deployed as a unit. Okay, so we can deploy the another version of its chart with the different sets of configuration. Okay, if you are using Helm 2, then Helm 3 we can like another version you can use it. Okay, the concepts of Helms are charts, releases, and a repository. So charts, it is a package consists of the pre-configured Kubernetes resources, and this and release, it's an instance that can be deployed to the cluster with the help of Helm. Okay, so repository is a group of charts that are available for others. So Helm charts are nothing but I just told you. It's a YAML manifest. Okay. So in the single package we can do it, and that is related to the Kubernetes. Okay. So once we install the Helm charts in our cluster, it is easy to running one single Helm, and one single Helm command, and it simplifies the deployment of the containerization applications. Okay, what are the benefits? So Helm is very easy. Without using Helm, also we can run the Kubernetes, not an issue. But Helm is the thing which reduce the complexity. Okay, okay, this is very easy. Everyone can understand it. It is very user friendly, and it is scalable. Okay, whatever the most of the companies will be preferring only Helm only. So just one command, and you are good to go. Okay, whatever the installations are there, you can do it. Okay, for example, when it comes to Ubuntu apt uh, okay, apt commands and Helm commands, whatever it is there, if you give one command, and all those things will be installed, and all the versions will be installed. So in the Helm 2, what happens? Helm 2 is used for the config maps. It is stored and release the information. And Helm 3 are the secrets are used instead of the default storage drivers. Okay, so in the Helm 2, we used to have the rollback access control. We used to not have that. Okay, so now in the Kubernetes we have role based RBAC we have in Kubernetes. So now it used to have the tiller actually. So it tiller used to manage everything. Okay, so now it's a client it's a now it only have the client thing. Okay, so Helm 3, in Helm 3 there is no use of this tiller now, because the Kubernetes is having the role based access control. Okay, role based access control is nothing but uh, giving the permissions, giving the access to the cluster. Okay, if the new user is coming, the cluster administrators whoever are there, they will be giving Kubernetes administrators whoever are there, they will be providing the access. They will be creating the service accounts. For example, if you are coming into a new company, if you're joining the new company, what they will create you a new email ID. Okay, new ID card. Okay, and he will be giving you the access for the so and so floor or so and so zone, right? So the same way here also for the Kubernetes, they'll be creating the service accounts and they'll be having some permissions. Okay, for the developers only, each and every person cannot go into the cluster and work on it. Okay, if you have the access, then only you are going to work on it. Okay, for the developers, they are having the limited access. Okay, for the administration level, they are be having the all the access. Okay, so for the users, there are different users will also come and work on the cluster, but only they have limited access. They won't work, they don't have access to work on each and everything. Okay, so GitOps. So when you come to GitOps, GitOps is ensures that the system cloud infrastructure, it is immediately, this is based on the state of the Git repository. Okay, if you know Git, this is going to be easy for you. So if you know the Git commands and all, so here we have the pull request and modifies the state of the Git repository. So once approved and merged, these pull requests will be automatically reconfigure and sync the live infrastructure to the state of the repository. Okay, why we have to use this GitOps? Okay, this will give the tools and a framework to take the DevOps practices. Okay, for CI/CD pipeline and version control and apply them to the infrastructure automation and application development. So we are using it as a infrastructure as a code. Okay, security as a code. We can use it to the many ways. So these developer can work in the code repository, so they already know while operations are put the other necessary pieces into the place. So what is the difference between GitOps and DevOps? So in DevOps, we will automate the things, like we'll do the development side and operations, both we do. Okay. So for automating the process of software development from start to finish, we'll be doing it like code testing, deployments, and monitoring. Okay, all these things comes under DevOps is just like a cycle. Okay, first you write the code, then you will send it to the testing purpose, then you will deploy it. Once you deploy it, again we have the monitoring tools. Okay, nagios and other tools are there. Okay, which we can, they will be monitoring how it is working and how it is running. This all these process comes under DevOps. Okay, GitOps, what it exactly do? It takes the more declarative approach. It will focus and treat the infrastructure as code. Okay, mostly infrastructure as code only will be using it. So mostly in the market, this is a new concept which comes here. So it is used as a infrastructure as a code, configuration as a code, security as a code, policy as a code, and network as a code. Okay, so we can compare it also. The comparison table also I have kept here. So this is adaptable to multiple tools. Okay, for this only specific techniques only will be using. Okay, in when it comes to tools, the main tools is Jenkins, with the other tools is Puppet, Chef, Ansible, used as needed. Okay, so Ansible is a configuration tool again. Okay, so when it comes to GitOps, we'll be use a Git version control system as a primary tools. The other tools are included Kubernetes, separate CI/CD pipelines, and infrastructure as a code. Okay, so for better flexibility is there. The flexibility will be less here, and less emphasis is placed on the here, and with the focus are correctness. Here, when it comes to focus, the frequent deployments and this is accurate will be there for this. Okay, how do you apply changes here? Like, how do you apply changes in the GitOps? So when you like apply the changes here, what happens is, um, first what you do, you'll take a piece of code. Okay, you take one repository or a registry. Okay, you just clone it and you just create the pull merge request. Okay, then from the main branch, if suppose you have one main branch. Okay, okay, from the GitHub or somewhere you have taken one thing and you have cloned it. Okay, from main branch, and then you have created a pull merge request. Okay, uh, then what you do, then you do make the changes there. Okay, then you run the CI pipeline. Okay, once you make the changes there. Okay, when the changes are approved, whatever the changes you have done, then you have approved, uh, then we have to run the CD pipeline. First we have to run the CI pipeline, then approve the changes, then we have to run the CD pipeline, and then the deployed to the environment. Okay, once you deploy to the environment, what happened, it automated the process. And it will be more transparent, and quality will be good for infrastructure as code. Okay, here in the pull, we have the two types of deployments here. Okay, one is pull deployment, one is push deployment. Okay, when it comes to pull deployment, we have the actual state and we have the desired state. Okay, the agent will be installed in the environment, for example Kubernetes cluster. Okay, and it monitors and compares the desired state with the actual state. Okay, and it applies the changes necessary to the desired state. The same things, what the actual state and desired state is there, once you learn the Kubernetes you'll understand. The same process will be, the same concept is there. The actual state is will be there and the desired state will be there. The target is we have to reach the desired state. Okay, so again in the pull deployment we have Orgo and Flux. Will be looking into Orgo as of now. Okay, so so no need to get worried. Once we are look, we have the separate sessions for this GitOps too. We will be taking the 6 to 7 sessions accordingly. So whatever the doubts we have and practice purpose. Okay, for Kubernetes also we'll install the minikube. Accordingly we'll do the practice. Okay, the same way how the for the Python and all, if you, the people will be using Jupyter, right? The same way for Kubernetes also we have a minikube. We'll be creating it. Okay, accordingly we'll run the commands. Okay, no need to get worried. So these are the benefits of GitOps. It will improve the collaboration and it will increase the deployment speed, and reliability, stability will be improved. Okay, and more flexibility to the things. Okay, and it is easy to deployment. So when it comes to career and all, when it comes to Kubernetes, when it comes to DevOps engineer. Okay, if you learn Kubernetes also, you can go as a Kubernetes uh, administrator, or you can go as a Kubernetes application developer also. So in the market, if you can see for the DevOps, there is a uh, high rating is there. So most of the companies are hiring for only DevOps engineers. So we are working on the different tools like GitOps. When it comes to DevOps, we'll be having Linux, Jenkins, Python. All these will be included here itself. So most of the companies are hiring only DevOps people, development and operations only. Most of the people are hiring, most of the companies. Okay, so for the other, when you can see the Python, there are very less people. Okay, only very the hirings are very less. So DevOps jobs hiring, most of the DevOps is in the highest place, which is 51%, and remaining for the software engineers and all, if you can see, only 18, 24, 26% are there. Okay, so for the test engineer and scrum masters, if you can see, only 11 to 14 to 15% people. Okay, so most of the DevOps now in the market, it is very good. If you can learn the DevOps, not only here, if you go international, like abroad, anywhere, like UK and Canada, wherever it is there. So these DevOps is working very good actually. The We are getting so many projects actually. So when you can see the different companies, TCS and Accenture, Amazon.com. So most of the company, this comes under product based companies, and top MNCs, each and everyone are hiring DevOps engineers more actually. So if actually most of the companies I have seen, if you not get selected also, the people within the less they will be giving you the second chance for the DevOps engineers. When it comes to Python developer or other developers, 3 months or 6 months time will be there. Okay, for the DevOps engineer, within they won't have any time, like after if you get failed in the interview, again the second interview they can conduct. That also I have seen, because the requirement is like that for the DevOps role. Okay, if you can see the payroll also is very high. Okay, for 1 year also they are starting with the 4 lakhs, like that. Once you have the 3 to 4 years of experience, then the packages will be like huge, mostly 12 to 15 lakhs package. Between that only you will be getting. So most of the employees are getting, when you get 2 years to 4 years, the person is earning around 15 LPA. That is for sure when you comes into DevOps. Okay, again if you have more than 5 years, then it is like around 20 plus you will be earning 20 plus. If you go into product based company directly, it will, for the people who have more than like 2 years. If the person is carrying 2 years of experience, then the person is having maximum. If you go with the product based company, then they will be offering you around 25, like that, like SAP and so and so product based companies. Okay, so DevOps is the thing which we are which is very good in the market. So you have to learn DevOps so that your career and jobs, everything will be going into the right direction.